and irrational numbers. Rational numbers are numbers that can be written as a ratio, or it can be written as a fraction. So a ratio is a fraction. So any number that can be written as a fraction is rational. That includes fractions, terminating decimals, or decimals that stop, repeating decimals, or perfect squares. All of those things are rational numbers. Fractions, repeating decimals, terminating decimals, or stopping decimals, and perfect squares. If it is not one of those things, it is irrational. So irrational numbers cannot be written as a fraction. They do not repeat, and they are not perfect squares. So we're going to look at these numbers and identify if they are rational or irrational. So number 1 says, which set below includes only irrational numbers? So I'm not looking for fractions, I'm not looking for repeating decimals, I'm not looking for perfect squares. One of these sets is all irrational. Ken, tell me which one it is. A. Okay, so let's look and see. Negative square root of 12. Negative square root of 12 is irrational because it is not a perfect square. Negative square root of 12 is not a perfect square, so it is irrational. If we look at the negative 0.76 with the bar on top, what does that bar mean? Repeating. Are repeating decimals rational or irrational? Rational. So this one is irrational. This one is rational because of the repeating decimal. So that one's not our answer. But let's go through. What is the square root of 36? Rational or irrational? It's rational because it's a perfect square. What do I mean by perfect square? A number times itself. So 6 times 6 is 36. So it's a perfect square, so it is rational. And the last one, 4.3858, ... Does it have a pattern to it? No. Is it a terminating decimal? No, because it has the ... Therefore, it is irrational. All right, so let's move on to B. We're looking for all i's. We're looking for all irrational numbers. Okay? Negative 7.2322 ... So you notice, hold on. 0.222 repeating. Is that rational or irrational? Irrational? Is that what you said? Because it's not repeating? Okay. It could be that the 2 is repeating. But this is going to be, and then let's look at the square root of 5. Is that a perfect square? No, so it's irrational. What about the square root of 15? Is that a perfect square? No. So that's irrational. And 8. So that was irrational. 8.27451 ... Irrational. So we can automatically say B is going to be our answer because they were all irrational. Okay? If we look at C, there's only a rational number because it's a terminating decimal. Negative 5.6 stops. It doesn't have the ... so it stops, which means it's rational. Square root of 14 is irrational. 6.3245 repeating is rational because it's repeating. And the square root of 81 is what? Square root of 81? It's rational because it's a perfect square. Because 9 times 9 is 81. So it's a perfect square. Okay? And D, negative square root of 8. Rational or irrational?
Rational.
Is it a perfect square?
Yes, it's 4.
No, 4 times 4 is 16.
Oh my God.
Okay, so this is going to be irrational. 0.37 repeating is rational because it repeats. How about this next one? 3.265165506 irrational. And the square root of 90.
Irrational.
Irrational. Okay, I'm just going to jump over here to number 5. Number 5. Which of the following is irrational? 4/3.
Irrational.
Rational because it's a fraction. The square root of 24.
Rational. Irrational.
Irrational because it is not a perfect square. Square root of 81
Rational.
because it's 9 times 9. And negative 4.07, stopping, is rational. Good. So that means B had to be the answer. Okay? And number 6, if we look at A, again, this time we're looking for rational numbers. So we want it to be a fraction, or we want it to stop, or we want it to repeat, or we want it to be a perfect square. Is A going to be the answer?
Yes.
Yes. 4 is rational. Or negative 4, sorry. 0 is rational. 1/4 is a fraction, so it is rational. And the square root of 9/4, 9 is a perfect square, and 4 is a perfect square, so it is rational. So that is our answer choice. Go ahead and finish the rest of these problems on this side, identifying rational and irrational numbers. You have 2 minutes.